Hey, this is Roswell. We're talking about a question from the AP1 physics sample exam in the 2004 course and exam description. It looks like this. Um, Three identical blocks each take a different path from a height h to the ground. Block A is released from rest and falls vertically. Block B is released from rest and slides down a frictionless incline. Block C is projected horizontally with initial speed of v. The questions that are asked are the following. Which block takes the longest time to reach the ground? And you could ask which block takes the shortest time to reach the ground. And you could ask, you can change that question up. Which block has the greatest speed just before, and you could ask which block has the smallest speed just before hitting the ground. All of those are valid. So here's what happened. I was thinking about a way to try and simulate this or describe it to people, and I remembered that there's a program called Algodoo at www.algodoo.com. It is for the iPad and also for heavy-duty kind of engineers and for the PC as well, and they have a bunch of people that are sharing stuff out there, so you could take a look. So here is what it looks like for this problem. I have block A, block C, and block B. I moved block B just because I had a little more room over there. Let's take a look at how this is set up. So for block A, you can look at its material. It is, first of all, it's steel. Just for the sake of an argument, its mass is 1.95 kilograms. It has friction. It has zero restitution, which we don't have to worry about right now. And let's look at its velocity. It has zero velocity, zero speed here at the beginning. What we're going to do is we're going to start the timer, and we're going to watch what happens. So that's this object. The next object is block C. Actually, block B was next, so its material is again steel, same mass. It has zero friction though, and here's the thing: this angled line here is a plane that block is constrained to slide against. It has zero speed, zero velocity at time zero. So that was block B. Next is block C. Block C is also made of steel. It's 1.95 kilograms. And its velocity is, now in this case, it's 3 meters per second velocity. So let's just visualize that. So we can draw an arrow here, and so that shows us that the velocity of block C. So this should be kind of equivalent to the drawing that we've got in the quiz. So let's just take a look and see what happens. I want to make sure this is set up here first of all. Okay, cool. And then this one here. Okay. So if I press the space bar, this simulation is going to animate, and let's see how it works. So what you're observing is how the blocks are behaving here under gravity. And then I can rewind that demonstration to here. So which block hit the ground first? Which block hit the ground last? This line here is the ground. So one thing that you can look at in this program is let's visualize the velocities, but actually here's how the program has some stuff set up. Let's view the velocities and let's show the components of the velocities. So now what I want to do is run the simulation and show you kind of what the components of the velocities are. So notice here, the total velocity of the blocks is shown, and the components of the velocities of the blocks are shown. So notice block A and block C both have a velocity in the vertical direction that's increasing. In fact, block A and block C are identical when it comes to gravity. They're being accelerated. They're in free fall. Block B, on the other hand, has an acceleration that is not equal to g because of the angle of this plane here. Its velocity actually is at all times less than these velocities for block A and block C. And then notice the magnitude of block C. The magnitude of block C is overall greater than block A. So one way to think about that is they all had the same potential energy at the beginning. Here at the beginning, we can go back. But block C also had kinetic energy as well as potential energy as block B and A. And that has to play out that as energy is added, as potential energy is added to the system, I think you can see that block C is always going to have more energy of the other blocks. So when it finally hits the ground here, and I can make the velocity show up on the screen. When it finally hits the ground over here, it's got a velocity that is almost 7.2 meters per second, which is greater than block A by quite a bit. So what I wanted you to see in this example was how a simulation could give some insight to you and to your thinking about how the physics is being played out in this situation. And so hopefully from the simulation, and if you wanted to build it yourself, you could see basically how these blocks are behaving and answer questions about them. So thanks for listening.